So far, we have gone through the various problems on Zener diode voltage regulator, in which the Zener diode is replaced by a voltage source, an ideal voltage source like this. Whenever the Zener diode undergoes breakdown, and across the Zener diode, instead of Zener diode, we are writing VZ, and the current through the Zener diode is IZ. This is what we have said. And various cases, right, as far as the design of a regulator is concerned, we have gone through. Now I'm considering the second case, like if the internal resistance of the Zener diode is taken into consideration, means instead of ideal voltage source, practical voltage source. How it is coming? Anyway, we have gone through this characteristics as well. Here, if you consider the slope, which is equal to 1 by Rz into consideration, what is the equivalent circuit of the voltage regulator? We need to see if Rz is given by delta Vz by delta Iz, which means it is not a perfect vertical line. The characteristic is not a vertical line. It is having some small slope. Okay, slope is extremely high, ideally infinite. So the reciprocal of the slope, if it is infinite, reciprocal will be 0. So Rz will be 0. But here the slope is not infinite, it is a finite value, but very large, reciprocal of that. In that case, what do we take instead of the Zener diode symbol? This point I have already mentioned. So it is Vz, Rz, and current going through this is Iz, and let V is the voltage across the Zener diode instead of Vz. V is equal to Iz into Rz plus Vz. This is what we can take. Now let us see some problems based on this representation of Zener diode. The first question. For the Zener diode shown in figure, the Zener voltage at knee is 7 volts. Okay, it is VZ is at knee current, the voltage is 7 volts. The knee current is negligible, and the Zener dynamic resistance is 10 ohms. RZ is given. If the input voltage VI ranges from 10 to 16 volts, the output voltage ranges from, okay, generally what do we expect? It is a Zener diode, it is input is around 10 to 16 volts. It undergoes breakdown and output is equal to Vz. In this example, it is equal to some 7 volts. That is a general expectation. But the thing is, Rz is given. As Rz is given, what do we take? Instead of the Zener diode, we have to, instead of a voltage source, what we write? We have to write a resistance series with voltage source. So instead of the Zener diode, I am writing like this. V input, it is a series resistance whose value is 200 ohms, Rz whose value is 10 ohms, and Vz, its value is 7 volts, and I is the current flowing, Iz I can say, and V output is equal to, right, what we can write, Iz into Rz plus Vz. We know that V output is equal to V. And what is Iz? V in minus Vz by 200 plus Rz, that is 10. So it is V in minus Vz by 200 plus 10, that gives us Iz into Rz is 10 plus Vz is 7. Okay, like this we can write, or Vz I can substitute what is there in it here. Then two cases, if input is 10 volts, what is the output? And input is 16 volts, what is the output? So if V input is equal to 10 volts, then output is equal to 10 minus 7 by 200 plus 10, 210 into 10 plus 7. It is 3 by 7, sorry, 3 by 21, 1 by 7. 1 by 7 plus 1. 1 by 7 means how much do you get? It is Okay, I mean 7.14 volts. I'm directly writing it. Similarly, so you can check, okay, two places we can see 7.14 B and C. Okay, so suppose input is equal to 16 volts, then output is equal to 16 minus 7 by 210 into 10 plus 7. So it is 9 by 21, that is 3 by 7, means it comes around 7.42 volts. So 42 or 43. Okay, 43 is there. So option C is correct. It's a very simple question. See, depending upon the data we are taking. Earlier we used to write a voltage source of value 7 volts in this problem. But now RZ is given. That's why accordingly there is a slight variation in the output. You will not get output exactly as 7. It is just slightly greater than 7. See this question. The current through the Zener diode and R1 in the given circuit are. Okay. So R1 or RL, okay, anything we can write it. No issues here. R1 given, we will write that one only. So current through the Zener diode. And here Zener diode RZ is equal to 0.1 kilo ohms or 100 ohms. Okay. Then how do we do this problem? Ten volts. It is 2.2 kilo ohms. RZ is equal to 100 ohms or 0.1 kilo ohm. VZ is equal to 3.3 volts. And R1 3. Okay, output is 3.5 volts, not R1. We do not know. We have to find what is R1. And output is equal to 3.5 volts. And current through the Zener diode, it is IZ. Earlier, previous problem, I and IZ are one and the same. Now they are not same. It is I and this current is IL. See, it is now a simple network. Once a circuit is given, can't you find various currents and resistors in the given circuit? That's it. That's the advantage. Analog means again it's like doing networks only. Right? From the given data, replace the devices, semiconductor devices by means of their equivalent circuit. Later it becomes circuit analysis or networks. Simple. Okay. So what is I? What they are asking, IZ first. Okay, V output is equal to IZ into RZ plus VZ, which is in this problem is equal to 3.5 volt. So IZ is equal to 3.5 minus VZ 3.3 by RZ, it is 0.1 kilo ohm. It is equal to 2 milliampere current through the Zener diode. So here you can see only one option has 2 milliampere. That's where we can conclude the answer. Anyway, we know that, right? And let us complete it for our confidence sake. So what about R1? To find R1, we should know IL. IL means I should know I. What is I? It is V in minus V output by 2.2K R. Earlier V in minus Vz by R we used to write. Now I am writing only V output, not Vz. That is the difference. So here input is 10 minus V output is 3.5 by 2.2 kilo ohms. So if you solve it 65 by 22, it is 2.94 milliampere, 95 I think so. 2.95 milliamperes. You get 66 by 65 by. So slightly less than 3. 66 means 66 by 22 means definitely you will get 3 instead of 3, slightly less than, I think 2.95 something you get. Once you get I, then we can find what is IL. IL is equal to I minus IZ. It is 2.95 milliampere minus 2 milliampere, it is 0.95 milliampere. So from this, R1 is equal to, instead of VZ by IL, we should write V output by IL. It is 3.5 volts by 0.95 milliampere. So 35 by 9.5, definitely you see 35 by 9.5, approximately 36 by 9 means 4. So answer should come somewhere close to 4 kilo ohms. Oh sorry, it has gone to the previous page. IL is equal to I minus IZ. It is 2.95 milliampere minus 2 milliampere, 0.95 milliampere. Then R1 is equal to V output by IL, 3.5 by 0.95 into 10 power minus 3. You will get it around 3.68 kilo ohms. Absolutely. Okay, that's it. Next. The Zener diodes D1 and D2 used in the circuit given in figure have breakdown voltages of 50 volts and 60 volts respectively. If the supply voltage is varied from 0 to 120 volts, then the breakdown occurs in, okay. Or what are the various stages where the breakdown is possible? It's something like this. Okay. So here the input is varying from 0 to 120 volts. Nice. And they have not mentioned anything about the knee currents and etc. Nothing to worry. Suppose the input is less than 50 volts, let us say. Anyway, similar kind of problem we did in clippers, if you remember so. Okay. So if the input is less than 60 volts, no diode undergoes breakdown and output is equal to. So if V input is less than 50 volts, then no diode undergoes breakdown. Okay. So what is the equivalent circuit, friends? This is open and this is also open. V input R RL, entire current goes like this. So our output is equal to V input by R plus RL into RL. Like this we can take. It looks like less than 50 volts, maybe. Next, if V input is greater than 50 and less than 60, what is possible? D1 can undergo breakdown and D2 is still open circuit. If V input is in between or 50 volts less than, V input less than 60 volts. So D1 undergoes breakdown and D2 is still open circuit. Undergoes Zener breakdown, of course. G2 still acts as open circuit. If that is the case, V input So VZ1, that is 50 volts. V output is equal to 50 volts. That's it. Further, you are increasing the input voltage. No issues. Is there any possibility for output to go beyond 50 volts? No. The input may be 55 volt or 60 volts. Doesn't matter. The voltage between these two terminals is 6. Here this is I and this current is IZ1 and this is IL. RL is fixed, IL is fixed, output is 50. Okay. Then if you increase V input, then definitely I will increase, which makes IZ1 to increase. But the voltage across these two terminals or across the output terminals remain at 50 volts. There is no scope for output to go beyond 50. Means even for 60 also the same thing, for 65 volts also the same thing, and for 70, 80, 100, 120, etc. For all values of input, only D1 can undergo breakdown. Voltage across D1 is 50. The same thing can be seen even across the Zener diode D2. So there is no scope for D2 to undergo breakdown. Even though I mentioned like 50 to 60, even after 60 volts, so even though V input is greater than 60 volts, there is no scope for D2 to undergo breakdown. V output remains at 50 only. And that's it. This is how we can do this problem. Okay, very, very simple one. This is already analyzed in clippers. Next, see this. The Zener diodes D1 and D2 used in the circuit given in figure have breakdown voltage of 50 and 60 volts respectively. If the supply voltage is varied from 0 to 120 volts, then the breakdown occurs in. Okay, actually in the previous problem, the breakdown occurs in D1 only, right? Here the conclusion is the breakdown occurs in D1 only. Okay, then see this. Here the input is varying. Okay, and if input is less than 50 volts, no Zener diode undergoes breakdown, and output is equal to, if V input is less than 50 volts, no diode undergoes breakdown. And the output is, anyway, here it is open and the second one is also open. R, RL, V input. V output, it is V in into RL by R plus RL. So very simple statement, we know. Okay, keep it aside. If V input is greater than 50 and less than 60, then what happens? Even though the Zener diode D1 is ready to undergo breakdown, it is in series with D2. It's not parallel like the previous case. So D2 cannot undergo breakdown. So means D2 is open circuit, and hence open circuit in series with D1. There is no scope for D1 to undergo breakdown. Okay. So if V input is greater than 50 and less than 60, the situation is 50 volts less than V input less than 60 volts. What happens? Even though D1 is ready to undergo breakdown, as D2 is in series with D1, so D2 cannot undergo breakdown, and hence D1 also cannot undergo breakdown. D2 anyway cannot undergo breakdown, right? Even though it is ready to, D1 is ready to undergo breakdown as it is in series with open circuit. There is no path for the current to flow through D1. So D1 is open circuit and D2 is also open circuit. That's it. Next, input is greater than 60. Okay, then what happens? Definitely D2 also cannot. Both are in series, right? If D2 is undergoing breakdown, D1 has to undergo breakdown. Okay. Suppose my input is series, and suppose, right, if you take some 55 volts here, it is, let us assume it is undergoing breakdown. If it undergoes breakdown, so voltage across this should be 50. Then there should be some current flow. No, is it possible for the current to flow through D2 which is not under breakdown? No. So no possibility for current to go through. So definitely this current is 0. Iz you can write it, doesn't matter. Iz is 0. Right, you may assume that knee current is, ideal value of knee current is 0, but there is no possibility for current to go through, and hence so anyway, as it is open circuit, there is no possibility for D1 to experience 50 volts across it. Okay, voltage across D1 means the voltage between these two terminals, that cannot be more than 50. Okay, then again you are making the input voltage around more than 60 volts, right? Maybe some 65 like this. D2 is ready to undergo breakdown. It looks like, suppose D2 is undergoing breakdown means D1 should also undergo breakdown. If both undergo breakdown, voltage across D1 should be 50 and voltage across D2 should be 60. 50 plus 60, 110 volts. Is it possible to get 110 volts from 65 volts? Meaningless. Both cannot undergo breakdown. Not possible. No diode undergoes breakdown. Okay, so how long it is possible? Even though I'm mentioning 50 to 60 or 60 more than 60 and all, till 110 volts. If V input is or 110 volts less than V input less than 120 volts, that time only both D1 and D2 will undergo breakdown. It is not possible to see only one diode to be under breakdown. Either D1 or D2. No diode undergoes breakdown if V input is less than 110 volts. So if input is greater than 110 volts, then both D1 and D2 undergo breakdown. Then we can see the overall output to be this way. Across this 50 and here it is 60 volts, and V input greater than 110 volts, or this is I, this is Iz, and this current is IL or L. V output is equal to 110 volts. Vz1 plus Vz2 can be seen across RL. Okay, this is the idea. Okay, so it's not possible for only one Zener diode to undergo breakdown, even though input exceeds the, sorry, even though the input exceeds the breakdown voltage of any of the individual diodes. Then see this problem. The IV characteristics of the Zener diode. So Zener diodes D1 and D2 are shown in figure 1, and these diodes are used in the circuit given in figure 2. If the supply voltage is varying from or varied from 0 to 100 volts, then the breakdown occurs in, right? Where is the breakdown possible? You see, if you observe the knee currents, right, they have given the things like this. Knee current 2 is less than knee current 1, and Vz2 is, knee current 2 is less than knee current 1, and Vz2 is greater than Vz1. No issues. Here they have not given the series resistance. Then what happens? As you keep on increase the supply voltage, right? Initially, some the negligible, very small amount of current will be flowing in the circuit because the characteristics are shown like this. There is a small amount of current. Then, first, just as an example, I'm speaking. It is something like 2 milliampere, and if you take it like some 1 milliampere, then what happens? Current first reaches 1 milliampere, which is the breakdown voltage of D2, okay, which is the knee current of D2. Then D2 starts undergoing breakdown. Once D2 undergoes breakdown, right? And there is a possibility for current to go through because of the characteristics, you can say. Suddenly, from 0 to 1 milliampere, the current cannot grow. The current slowly increases. So, whenever the current in the circuit reaches 1 milliampere, then immediately D2 undergoes breakdown. Once D2 is undergone, so what I can say, D2 only I can say, because for D1, if D1 also undergoes breakdown, then what is the voltage across these two terminals? I can say if D2 is undergoing breakdown, voltage across D2, it is 70 volts, no, 70 volts. And what about voltage across D1? It is V input, actually V input is equal to V1 VD1 plus VD2, and VD2 is 70. If that is the case, okay, VD1, it is equal to V input minus VD2. It may be, right, suppose input is some 75 volts, 75 minus 70, it is 5 volts. Input is 80, 80 minus 70, it is equal to 10 volts. And input is 90, 90 minus 70, 20 volts. And 100, 100 minus 70, 30 volts. So there is no scope for voltage across D1 to reach its breakdown voltage. Okay, as the knee current of D2 we have achieved, definitely D2 will undergo breakdown and D1 cannot undergo breakdown. That's what we can understand. So D2 alone only undergoes breakdown. D2 is under breakdown and D1 is holding a voltage equal to V input minus VD2. Okay, so only D2 undergoes breakdown. It's not like none of the diodes D1 and D2. If they have not mentioned the characteristics, then we can say like no diode undergoes breakdown. But they mentioned the characteristics. In the previous problems, they did not mention the characteristics. That's why what we did, if both no diode undergoes breakdown. Right? It's not like we have achieved the breakdown voltage knee current of one diode. Such thing is not possible in the previous example. If you take this example, you cannot say so. Okay, nothing is mentioned. But in this problem, right, it is clearly given, mentioned the characteristics. So whenever the knee current of D2 reaches, then D2 undergoes breakdown and D1 cannot undergo breakdown for this particular value of input. If the input is around 150, then there is a scope for D1 also to undergo breakdown. D2 and D1 will be undergoing breakdown if input approaches 150 volts. Okay, you can't apply the input more than 150. If you apply it, so then it is an imbalance equation because the entire input should appear across D1 and D2, but D1 cannot hold more than 80, D2 cannot hold more than 70. Altogether input is right, should be equal to VD1 plus VD2 should be equal to V input, as there is no series resistor here. If you have some series resistor here, then okay, that is a different story. Okay, but here we do not have the series resistance, and hence right, anyway, right, the input is given as 0 to 100 volts, nothing to worry. If input is given up to 150, then there is a scope for D1 also to undergo breakdown, and you cannot apply the input more than 150 in this example. Next, See this. The IV characteristics of the Zener diodes D1 and D2 are shown in the figure. The diodes are used in the circuit given in figure 2, and if the supply voltage is varied from 0 to 100 volts, then the breakdown occurs in. It is something like right here VD1 has a knee current of just as an example I'm speaking 1 milliampere, and VD2 has breakdown voltage is less but the knee current is more. As an example I'm speaking, it's not the true values, just for our understanding sake I'm speaking. Then which diode undergoes breakdown? Definitely the diode with low knee current undergoes breakdown. So the current through this one is flowing, right, flowing in this direction. If it exceeds the knee current of 1, then D1 undergoes breakdown. And what about D2? We know here V input is equal to VD1 plus VD2. Then VD2 is equal to V in minus VD1. So what about VD1? VD1 is equal to, it is 80 volts, and VD2 it is V in minus 80. Input is 90 volts. So even though input is 70 volts, the knee current of D1 is not approaching. We have not approached that value, reached that value. Input is 80 volts. That time we reach the knee current of D2. That knee current of D1, and D1 undergoes breakdown. So after 80 90 volts, then if input is 90, then it will be 10 volts. Input is 100, then VD2 will be 20 volts, like that. And you can go to a maximum input of 150. You can't go beyond that. When V input reaches 150, then D2 undergoes breakdown and overall output is equal to 150. That is possible. So from the given characteristics, what we can understand is only D1 undergoes breakdown. See, breakdown voltage is more and the knee current is less. That is an interesting thing. Possible. In that case, as the knee current is for D1 is less, even though breakdown voltage is more, that only undergoes breakdown first. Even though we may reach, the input may reach 70 volts, as the knee current of D2 is less than that of D1, D2 cannot undergo breakdown. Okay, that's it. This is how we can do this problem. Okay, it all depends upon the characteristics of the Zener. That's where the regulators are